Okay, so welcome everybody to a new Friday afternoon NORA webinar. This fall we have webinars every other Friday, so the next webinar will be the 25th of September. And today we have Jill Walker Rettberg here as a talker. She is professor at the University of Bergen, and today she will talk about what kinds of knowledge can AI provide, the epistemology of AI and machine vision. So please, Jill, just start.
Thank you very much. So epistemology of AI. Epistemology is this big word. I have to admit, I love it, but it's also a bit intimidating, right? So let's look at what it actually means. Oh my, now my keyboard won't move forward. No. Let's see. Oh, there we go. Epistemology. Okay, you might remember this from Examen Philosophicum if you have a Norwegian degree, or philosophy classes at some point. Epistemology comes from the Greek episteme, which is about knowledge or understanding, and then logos, which is reason and account, argument. So it's a very reasonable, we're thinking rationally and we're trying to build knowledge here. Ontology is another relevant word, I think, because it's, according to the philosophers, the metaphysics of being. So what is? I mean, is this cup? Is it a thing? But of course, in computer science and information science, it's more often used as a very sort of formal, explicit specification of categories, a hierarchical, how your database is designed, etc. But it also is part of the epistemology of AI, because we have data, and what is that data? So in the following, I'm going to be talking about a few different ways in which AI and machine learning build knowledge or enable knowledge in quite particular ways that might be quite different from previous ways that we've tended to build knowledge. So I'm going to start a bit historically about, how we construct knowledge. And then I'm looking at three sort of areas of this epistemology of AI. I'm looking at the data sets, looking at how the neural networks actually work and how that impacts the kinds of knowledge you can generate with them, and also looking a bit at the social. And this is not going to be a complete everything about the epistemology of AI, because I think we're just starting to scratch the surface of how this is working. So it's some points, and I really hope that you guys will fill out and critique this in the discussion afterwards. Okay, so Western science pretty much relies on classifying things. And we've been doing this since at least Aristotle, but this is an example from, the biological, the Linnaean taxonomy that's been really well known since for the last few centuries, where, you divide things into big categories and then smaller categories, and you build your hierarchies. This is the way that we've really designed, the scientific method, and it's also something that computers and computational systems really tend to build upon. It's not the only way of developing knowledge. For instance, many indigenous cultures don't think hierarchically. They don't have the same kind of, we must classify everything. For instance, I've read this article by Michael Christie, who built a database of Australian Aboriginal stories, and was kind of surprised when he showed the Aboriginal people his database, and they were like, that doesn't make any sense, because they hated the hierarchies and the categories. And what the solution for that was to build a more flat structure. So instead of having your classic database, you've got just something that's sort of more like a folksonomy of tags across, where you can freely search across. So that's a particular kind of different knowledge. But it's not just science that's been part of how we've designed this Western classical way of designing knowledge. Accounting and commerce has also been really important. Double entry bookkeeping, for instance, bookkeeping and tallies and keeping track of your grain stores and your money has been one of the reasons why we've developed writing in the first place, way back a few millennia ago. And then in the 12th, 13th century, double entry bookkeeping was developed in Italy, in Korea, and it's still the way that modern accounting works. But there's also a more dubious history to all this. Jessica Marie Johnson is a historian of Black African-American culture, and she talks about how the slave trade actually was part of the sort of motor for developing techniques of keeping track of people and developing, well, basically data structures, right, for selling people. And also tracking productivity. They tracked productivity of enslaved people, like kind of like we used Fitbits nowadays. So there's all these different sort of histories that are actually kind of the underpinning of how computers work in the 20th and 21st century. Another thing, a historical important point, is the invention of statistics. So in the 18th, 19th century, nation states started gathering demographic information about their populations and using statistical analysis to analyze them. So one sort of maybe unexpected thing that happens from that is that you get this idea that there is something called normal. This is Leonard Davis. He's a disability studies scholar. And he points out that the idea of normal actually had to be invented. Like 500 years ago, people didn't think about average or normal as being anything you'd sort of want to be. They had a more ideal version of what beautiful or was, right? You've got Venus coming up out of the ocean. Whereas then you start measuring people and you see, oh, if you're not this exact height, you know, then you're a weird, you're an aberration. So the idea of normal is also something that is important in machine learning and AI. And we've got other ways of using data, a lot of data, to generate new knowledge, like Florence Nightingale, who gathered data about all the deaths during the Crimean War at the same time she was working 20-hour days as a nurse. And she found, you see the red bits in the middle of this diagram show people who died because of actually being wounded on the battlefield. And then the blue sections are everybody who died of disease. And so it's plotted around according to the time of year, and it shows very, very visually that, you know, people are dying from disease, not from being wounded. But then AI does stuff kind of differently, right? It's definitely based on data, and there's definitely statistics in there. But some of the things it comes up with are very different. This is from an art exhibit, but the images are actually taken from Yuki Yasu's Kamitami's lab, and he was doing brain imaging and showing people photographs, and then getting training a neural network on that, and then giving the neural network new photographs and asking it to generate these images. So often we experience what AI comes up with as strange, creative. This is not like Linnean taxonomy and clear structures, right? I should also say that when I'm talking about AI, I'm not really talking about general AI. I'm talking about machine learning, neural networks, all these things like the facial recognition or image generation. So what are the epistemologies followed by AI? Are they like the sort of the normalizing, statistical, categorizing structures of Western science and commerce? Or is this something else? So I'm going to look at three different areas. I'm going to look at data sets. I'm going to look at the way the neural networks actually work and manipulate the data. And then I'm going to look a bit at the social contexts. So this is a very basic diagram of how machine learning with a supervised data set works. I actually used this at the Children's University, which was fun. So basically the idea is you have a set, many more than 6 images, of course. You have a set of images, a data set that's tagged, you run it through the neural network, which identifies various features, has many layers, and it comes up then with predictions if you show it a new image, for instance. And this works pretty well. I mean, you can take huge amounts of data. The way it works also means it's not very transparent to humans. So it's a bit vague to us how it figures out that that's probably a cat. And it makes weird mistakes sometimes, right? They're like, sometimes you can change a few pixels in that image of a cat and it will think, the neural network will think that it is probably guacamole instead. It's weird. Okay, so I don't know if you have the app that's actually called Google. It has Google Lens in it, so you can point your phone at an image and it will try to identify it using image recognition. And it works beautifully for a lot of things. I pointed it at a photo of a cat and it correctly says, oh, that's a cat. And here are some different species of cat it could be. If you point it at a picture of a gorilla, it says, no results, sorry. And you might know why. That's because Google Photos incorrectly identifies African-American people or people with African features as gorillas, which is a horrible mistake to make, and also builds upon, you know, centuries of racial stereotypes that are quite problematic. Now, this image is from was posted by the woman in the bottom picture there, who was upset not unexpectedly. The thing is, this is from, I think, 2016, and Google hasn't managed to fix it. They haven't managed to stop their algorithms from identifying people with African features as gorillas. So their solution is simply to not tag anything as a gorilla. So there's this bias problem. There's an obvious reason, which is that the data set was perhaps not representative. So, I mean, if you train your facial recognition system on all white men, then obviously it's not going to do as good a job at recognizing Black women, for instance. And this is something Joy Buolamwini and a number of other people have pointed out with their auditing of facial recognition systems, which find that, sure enough, they don't recognize dark-skinned people and women as well as white men. And this has been improved by many of the companies by simply diversifying the data set. So that's problem number one, really. What is the data that you are training your model upon? A second problem is, what does the data actually mean? I mean, it's one thing showing it faces and saying, okay, is this a human face or not? It's a different thing when you start using proxies for what you're really trying to look for. So for instance, emotion recognition, you are using the facial expressions, which can be measured, as a proxy for how the person actually feels. And the thing is, psychologists have shown, this is a recent study, which I'm showing here, going through, it's a lit review going through, you know, hundreds of psychological studies looking at the relationship between facial expressions and emotion, and finding that there actually isn't a one-to-one relationship there. Facial expression does not necessarily convert directly to emotion. So you've got this whole industry of emotion recognition software that's built upon using a proxy that might not really connect to what they're trying to measure. And this is quite problematic, since emotion recognition software is being used all over the place. I mean, the most obvious, probably the most commercial use of it is people making videos or ads or something, and then they run software to see whether people, how people are responding to the video ad, for instance, right? Are they happy? Are they sad? But it's also being used, for instance, in schools in China to check whether students are paying attention or are looking tired. They actually get little automated messages sent home to their parents saying, your child was grumpy today, 7.3% of the time. There's a lot of other examples of how AI models are often trained upon data which is actually a proxy for what you're trying to find out. And so that's something, an ontological problem, a problem about what is being, what is the thing that you're trying to study, right? This, for another issue actually, is, okay, so problem number two, the data is a proxy for something else. But another issue is that often people actually, the data set is made up of actors acting out the emotions, which I think must be the case in this not very good image of fear. But for instance, when they have supermarkets where they have cameras trying to pick up who has suspicious behavior and might be a shoplifter, the data set is actually actors. They've taken videos of actors pretending to be shoplifters. So the data set is like 2 steps removed from what you're trying to measure, right? Because it's not even video of a shoplifter, it's a video of an actor pretending to be a shoplifter. So this is quite a problematic question ontologically. In digital humanities, this is the title of a book, but it's also like an axiom pretty much of digital humanities. Raw data is an oxymoron. It does not exist. There's no such thing. All data is constructed in some way. And I realize that probably feels a bit different if you're measuring something really hard, like, well, it's raining in Bergen today, and I could measure how much rain fell, and that maybe is raw data. These things become much more obvious as soon as people are involved, but a lot of AI does deal with people. Okay, so there are more things we could say about the data and data sets, but let's move on to the working of the neural networks. And this is where it gets kind of tricky, and I'm really hoping for more input. I've just got 2 possible problems here, but I think there are many more. So first, one problem. The patterns that the AA find might work only in very constrained situations. So for instance, you've probably heard about that example where the neural network picked out pictures of wolves and differentiated them from pictures of dogs, but it turned out it was only because of the snow in the background for the wolves. So actually that example, when you look into it, it's not as juicy as it looks in the magazines and newspapers, because actually that was a data set that was deliberately made by researchers to be a bad data set. They had 20 pictures, 10 of huskies without snow in the background, 10 of wolves with snow in the background. And they were doing this to try to design ways in which you could get the machine learning to then report back and explain to you why it identified something as a husky or as a wolf. And in this example, you can see it's misidentified a husky as a wolf because there's snow in the background, but it shows you why, and it shows you that it's not paying any attention to the husky itself. But this isn't just something that happens with bad data sets, or perhaps all data sets are inherently bad, I don't know. For instance, Tesla's autopilot can be fooled by, if you put stickers in the road, then you can just put a few stickers in there and suddenly, oh, it will drive on the wrong side of the road. Or person recognition, if you hang up some funny pixels on yourself, it won't see you as a person, for instance, which leads to people coming up with anti-facial recognition makeup, for instance, so could be good. So basically, in a lot of situations, the neural network will work in most situations, but not in what might be quite important situations. Problem 4. Synthetic data generation tends towards the average, so it reduces diversity. Okay, so synthetic data generation is where you have your data set, your training data set, but it's not really big enough or comprehensive enough. So you generate more data based on the initial data you have. And here, this one gets confusing, and I would love input on this one, because I have read several papers arguing that this leads to more bias in the data, or rather, it sort of shuts out the unusual categories, which means minorities tend to become invisible. Now, my research is mostly on machine vision, so I've been reading a lot about facial recognition. So this is very much data about humans. But examples I've seen, for instance, are where a data set was taken of computer scientists in US universities. So you can get 10,000 photographs scraped from web pages. And of course, the percentage of dark-skinned women is pretty low, for instance, right? But when you generate synthetic data based on that data set, then it tends towards the normal, kind of like the statistics in the 19th century. And so you get even more pictures of white men and even fewer pictures of black people and of women. So that would increase the bias. However, I've also read about, this is a number recognition software where they were trying to use generative teaching networks. They were trying to generate more synthetic data based on the many, many handwritten digits they had. And you can see a lot of these, this is some of the generated digits. And as you can see, they look really weird. They do not look like digits. They don't seem normalized at all. And the authors of the study actually call it alien, which is an interesting term, I think. They argue that maybe, they're not quite sure, to be honest, why the alien digits seem to actually lead to better results, because the neural network actually performs better with this synthetic data, even though it looks really weird to a human. They think maybe it's sort of making these bizarre edge cases that allow the network to differentiate between different kinds of things in a better way, but they're still kind of unsure. So maybe synthetic data maybe leads to bias, or maybe not. Another problem is overfitting. Overfitting is where so the top image here is an example of overfitting, and you're including too much detail in your model. And if you do that, you won't be able to make any useful predictions. You really need some generalization in order to be able to predict anything, really. So the bottom image shows an example where it's regularized and not overfitted. However, that means you're ignoring the aberrations, right? You're looking more at the normal and less at the edge cases. The problem is edge cases can be incredibly important, like that Uber car that killed a pedestrian last year, because it was programmed to, it was told that if it shouldn't consider that a moving object might be a pedestrian or a human unless that human was on a crosswalk. And so when a pedestrian jaywalks and crosses the road not on a crosswalk, then the model cannot conceive of that being a human. And so it did eventually identify it as a bicycle, but it took much too long and the pedestrian was killed. So that could be an example of overfitting, which is necessary to be able to make any predictions, but in really important cases completely fails. There's a pile of other examples of sort of epistemological things, problems or differences with AI in terms of how the neural networks work. And like some of them are, I don't have slides about them because I haven't thought through them properly, but one of them is, for instance, what the goal of the algorithm is, right? So for instance, YouTube's algorithm, its goal is to increase profit for YouTube by getting people to watch more videos. So it's going to analyze all the data and try to figure out, okay, what do we do? What do we recommend to people so that they spend more time watching videos? It turns out that you watch more videos if you get angry or upset. And so the recommendation and algorithm ends up showing people more content that's going to upset them or make them angry or scared, right? Which leads to more extremist things, to more conspiracy theories. Nobody at YouTube programmed the algorithm that way, but the point is that the algorithms will, the neural network will try to fulfill the goal no matter what. And so the actual, what it ends up doing can be different from what the humans who set it going meant it to do. And there are more examples than that too, but later. Social contexts. The social is an important part of it because, you know, AI and machine learning, they don't operate alone. We set them going, we respond to them, we think about them. And one of the issues here is that we humans get really, we get very impressed by data, you know, we believe in it. Joseph van Dijk, she's a professor in Amsterdam. She has this term dataism, which she says is an almost ideological belief in the objective quantification and potential tracking of all kinds of human behavior and sociality through online media technology. So what she's saying is that this idea of dataism is that we tend to believe data. There's so much of it, and if it's called data, and if you like are told, you know, we've got a billion data points and this very clever algorithm, we tend to believe in it or think it's true, which can be absolutely fine if you're modeling the universe, although sometimes those models are wrong too. But when it comes to humans, it can be quite problematic. And this has been described by scholars as, you know, there's this fantasy of knowing, like you have access to everything because of this huge data set. Donna Haraway called it in the 1980s, she called it the God trick, where it seems as if you're seeing everything from nowhere. And she's arguing that actually knowledge is always situated in some sort of context. But I think there's also this aspect where we're sort of swept away by this sort of sublime feeling, right? This is a famous painting from, you know, the Romantic era, Friedrich's Wanderer of a Foggy Sea or something like that. And it shows the, you know, the person who is just viewing the sublime nature and is just, it's this wonderful feeling, right? I think we feel that way sometimes with AI. So the sublime, it's an old concept. Longinus, back with the Romans, you know, he was talking about how in his rhetoric, he talked about how a sublime speech can overwhelm the audience and overcome their rational abilities. And I think that's interesting because there's this tension between the sublime and this feeling of awe and overwhelm and the rational. Kant, more recently, not very recently, he talks about two different kinds of sublime. The dynamic sublime is the kind, you know, this kind where it's like this huge thunderstorm and it might sweep you away and you might be killed, but it's amazing and you feel this sort of awe when you see it. And then there's the mathematical sublime, which is this odd term, but what he means is that you're in awe of something that is absolutely large. It's not, by absolutely large, he means you can't compare it to something else. You can't really measure it. It's just so big, you cannot comprehend it rationally. So for instance, these are the 7 mountains around Bergen where I live, and you can measure how tall a mountain is. And you can say Ulriken is taller than Liderholm. So they're not absolutely large, even though they are pretty big. Space, on the other hand, I cannot comprehend how large that is. I can't actually grasp it rationally. And so that gazing into space is, or imagining space, is this mathematical sublime. And I think big data and AI play upon that. When something's so big that you can't comprehend it rationally, then it's sublime and we're overwhelmed. And that actually leads to a problem. Oh, I've got the numbers wrong, but don't worry. We're swayed easily by the vastness of these data sets. And I think the fact that we can't necessarily understand exactly what the neural networks are doing adds to this sense of there's this sublimity. We can't rationally comprehend it, so we're slightly in awe. So my last problem is this idea of the tech fix. And that's really the idea that technology is going to be the solution to everything. And sometimes other things might work better. Often technology can really help hugely, but sometimes maybe that's not really the problem that we're trying to solve. Like, you know, in Norway, the IB students got their predicted exam results instead of their actual exam results. And the same happened in the UK, where A-levels. So because the students couldn't sit their final exam, they, the UK and the IB, the International Baccalaureate, decided, well, we'll predict exam results. And this is the algorithm for it. And as you can see, it's not actually, that's not really machine learning, but it is an example of this kind of idea that using an algorithm and using big data to predict something is going to be the solution to things. So there was an algorithm that built upon, you know, the students' previous grades, but also the historical grades of their whole school and other things as well. And this actually meant that students from poorer areas and schools where people didn't do as well got worse grades, even if their own personal achievements might have warranted better grades. So in this case, the problem was sort of said wrong, right? I mean, because they think, oh, students can't do exams because of COVID, so we need to predict what grades they would have got, so let's use an algorithm. Whereas the real problem, or you could have formulated that problem as, students can't do their exams, so how are we going to make it possible for employers and universities to figure out which students to admit or to hire? And if that's your problem, you might come up with a different solution than predicting grades based on other people's grades. So I just want to finish off with a little bit of philosophy again, really. And this is going a bit beyond the, well, no, it's sort of epistemology as well. So you might remember in 1996, Deep Blue, an early form of sort of AI, was the first computer to beat a human at chess. Beat the human champion at chess. And back then, Deep Blue, that's Deep Blue in the cabinet. Well, actually, I think it's only part of Deep Blue. It was a big, big computer. Back then, Deep Blue was presented or represented as if it was like a competitor, like the robots might come and kill us and, oh, this is dangerous. But it was also represented as being human-like. I mean, maybe it doesn't look like that in its cabinet there, but it was presented as similar to us, but different. If you imagine like HAL or one of those old sci-fi AIs, there's also this sort of imagination of like, they're very like humans, but potentially dangerous, right? Competitors. And then a few years ago, AlphaGo was a neural network-based AI, which for the first time beat the human champion at Go, which is a more complicated game. And this time, it was presented not as a competitor to humans. I mean, in this case, it obviously beat the champion, but it was presented more as, it made these beautiful chess moves. It was made unexpected and unhuman, sort of almost alien choices in the moves it made in the game. People were saying a human would never have made that move, but it's gorgeous. And they were presenting the potential for this AI as being a collaborator with humans, like it does something very strange and unhuman, but we can work with it. And so this brings us to this idea of the assemblage, this working together of humans and machines, which is very much the, a strong sort of theme in contemporary critical theory now. It's also emphasized in ads. This is, I think, Deloitte. The power of with, it's like human eye with the computer vision stuff on top of it. It's like humans and computers. And this echoes, you know, critical theory like Donna Haraway's feminist cyborg manifesto from the 1980s, where she says, forget about these binary oppositions. We're all cyborgs, you know. Everyone is not, it's not like nature versus culture. It's like we're all these mishmashes working, computers, technology, humans all meshed together. Catherine Hales is another thinker. This is a book from 2018, and it's called Unthought. And in it, she argues that cognition is something that humans do, but also computers do, animals do, maybe plants do. So she separates, she says, non-conscious cognition is the stuff we do where we just, we interpret information in a context and we connect it with meaning. That's her definition of cognition. So when I breathe, all the things that my body does automatically, or also when I just recognize someone's face without really thinking about it, that's all cognition. It's a fairly low level, well, it's a low level cognition. I also think, and when I think, I'm aware of myself thinking, and I narrate things to myself and so forth. So using that definition of cognition, then clearly computers cognize, and animals and many other species, which lets you think more freely about how these collaborations, how these assemblages actually work. This idea of the assemblage is also been really important in this recent sort of movement towards vital materialism or new materialism. It turns out, you know, in the 80s and 90s, there was this idea of social constructivism. So the idea that society actually alters technology, or everything's socially constructed, right? Everything's relative, etc. But before that, there were these vitalist or materialist philosophies, which are more interested in the thing itself. And in this new materialism, people are thinking about the ways that the different things and computers actually have some sense of agency. They do things. It's not just all socially connected. So Jane Bennett talked about, for instance, the blackouts. This is her example, some of the blackouts in the US in the early 2000s, which are not the fault of any one individual or a human or a computer system, but it's this mix of coal, sweat, electromagnetic fields, computer programs, electron streams, profit motives, etc. So it's this assemblage. So that's a way of thinking about how AI and humans work together that I think is really interesting and useful. So to conclude, I have these 6 problems. I'm sure there are more. I would love to hear what you think about this and what kinds of knowledge, what kinds of information we can actually generate by using neural networks, AI, machine learning in collaboration with human beings. Thank you.
Thank you so much, Jill. Great talk. Thank you very much. I have really so many questions, so I don't know where to start. But by the way, everyone, just please write questions in the Q&A button or the chat below, and I will read them up for Jill. You were talking about everything from cognition to intelligence to many topics. One thing that you didn't touch upon, I know that you're also in the Norwegian government's privacy commission, or whatever it's called.
Yes.
What do you have some thoughts about privacy in the context of data here and artificial intelligence?
I do, and I mean, it's interesting. We had our first meeting in the Privacy Commission, Personvernkommission, like, was it last week? Maybe the week before. And it's got a host of lawyers. There actually are, well, there are people who know about technology, but there's not like a computer scientist in there, which I thought was a bit interesting. Maybe a problem, we'll hope not. But I think one thing that AI and machine learning clearly does to privacy is you can use the data in these completely new ways, which you couldn't before. And so data that might have been okay for it to be, like Clearview, for instance, the facial recognition company that just scraped all of our public profile pictures from Facebook and Twitter and so forth, completely against the GDPR, but they don't care. And now they've built facial recognition based on that they're selling to police departments all over the United States. And they even had a trial lecture at the Norwegian police, or a trial license at the Norwegian police. And that's just something that there's no place for that in Norwegian law, or really, well, yes, the GDPR does stop you supposedly stop you scraping images, but people do it anyway. And I think there's going to be so many more examples of that. There are some, it was interesting, we had a sort of run through by a lawyer of what the GDPR says. And they brought up Article 22, which more or less says automatic profiling is illegal. And that is one of the things that's made the IB people take away their grades, for instance, because it's in breach of, it's an automatic profiling that you haven't agreed to. But there's so many exceptions to it. So for instance, I asked, well, what about the bank when they just automatically run information, not just on me, but probably on my neighborhood where I live, whether I rent my flat, maybe my friends and family, who knows, to determine how big a mortgage to give me. And because you're allowed to do that automatic profiling because it's part of a contract or an agreement. So what about a customs officer who uses automatic profiling, looking at all my social media friends and my past history and so on to see whether I should be picked out to be checked in case I'm smuggling wine or something. And that would also not be against the GDPR because a human would be involved, because a human would look at all the list of recommendations from the system and pick some of them. And so it's sort of interesting. They're sort of trying to figure it out, but yeah.
Yeah, and you were talking about working together with AI, right? This is important. And for example, in medicine and radiology, you will see a lot of radiologists working with AI tools. So this working together, but in health particularly, and also with respect to the data and privacy. Norway has a lot of the health data, and we these days also get more and more health data, and wearables are coming and so on. And these are often also sensitive data. It has been said to be kind of a gold mine in Norway to have all this health data, but privacy is a big concern in that respect. Do you see any ways to because it's also a dilemma not to use this health data, right? It could cure diseases.
Yeah.
So do you see, in your work with privacy, how should you solve this?
Really tough question. And I just recently read a study of a comparison of Finnish and Danish ways of dealing with this using public health data for private corporations, because it's sort of a gold mine, right? The Nordic countries do have all this health data, and it could save diseases, it could save lives, right? But it's also very problematic, as you say. So yeah, this is another one of the questions we're gonna have to figure out. I don't know.
Do you think the answer is ethical or juridical or maybe technological? I mean, you still have tools like differential privacy, distributed learning and so on. Do you think those tools are good enough to solve kind of some of the issues?
They certainly go a fair way towards doing it. I think it's going to take us a while to work it all out. The Privacy Commission, like the mandate we got from the government, said to consider options like certification, like maybe should people who work with AI in those ways have some kind of certification? And if so, what should that be? The problem is there's so many strange ethical things that you might not have thought of before you've done them that it's really quite challenging to figure it out.
I know people who want an algoritmetilsyn in Norway. We have a datatilsyn, but we don't have an algoritmetilsyn. What do you think about these ideas? Are these possible even? Because as you said also earlier, especially these deep networks, they're so hard to understand. We don't understand how they kind of predict cats from cat images in some sense. And also my background is in neuroscience. We don't understand the brain. It's still exciting to see when you train networks, you could start with very different parameters, but you have some general rules. So they will become similar in how they predict things, even though they start with different parameters and end up also with different parameters, but still they predict as good. Yeah, back to the question. If you don't understand these networks very well, I mean, how could we even think about algoritmetilsyn? How should we do this kind of? It's hard questions, but do you have any thoughts about that?
I think we should be trying to make, transparent AI or understandable AI. Like, there are people attempting to make AI explain itself. Like the image I showed of the dog and the husky and the wolf. They are actually making a system that will point out what bits of the data were used to achieve that prediction. And we could certainly require more of that, right? I also think some legal regulation of some things, clearly how to use health data, but also, I mean, if you start using health data to triage, to say, oh, we should be helping those people get better rather than those people. You need some kind of regulation figuring out, okay, what is that based on? And in the legal system, like facial recognition, there's a number of states in the US that have just banned its use for now, which it is kind of outrageous. We've had facial recognition use by police, for instance, and private companies for 10 years without there's no laws, like nothing. It's, so we do need some more regulation. I don't know about algoritmetilsyn. Couldn't datatilsynet do the same thing, or just?
Oh, maybe. I don't know too much about it, but we have to solve this privacy issue problems. It's very important. So we have some questions from some of the viewers. First, quite a long question from Thomas Smits. Thank you very much for this wonderful presentation. McKenzie work noted that discussions of the increasing influence of ML models are frequently sidetracked into the demand for a fairer algorithm, as there could still be a neutral third party above our differences from which to pray for not much more than an equal right to be exploited by asymmetries of information. Are we as researchers not sidetracked in discussing ML fairness by the entities, companies, and states that use both ML models and discourses of objectivity and neutrality to increasingly exploit asymmetries of information?
Yes. Yeah, I mean, if we get fairer facial recognition algorithms, for instance, that can recognize Black people more easily, it still just helps build a surveillance state, right? So this is a good point. And yet, I mean, yes, of course you can argue that capitalism is a problem, but there are also ways in which one could maybe curtail some of the algorithms. Like, it's very hard to see how you do it though. I mean, for instance, it's clear that YouTube's recommendation algorithms are built to get profit, and they lead to conspiracy theories being more prevalent in society, right? Which is obviously a problem for democracy, but how do you stop that? Do you say, oh, you can't make your algorithms so that they encourage anger? Like, that doesn't, you can't do that. How would you do that? Do you just ban all recommendation algorithms? It's a very, very tricky question, and I do not have the answer.
Oh, many good questions and hard to answer them. Thanks for a great presentation. This next question is from Surendra Gikianash. I'm wondering about an algorithm trained to filter candidates for hiring interview for an advertised position. How would you think dataset should be prepared to avoid any bias towards gender and race? Thank you.
Oh, well, this is a tricky one. That sounds like someone's trying to do that. I know a few ways it can go wrong. Like if you use historical data, I'm sure many of you have heard about when Amazon tried to use machine learning of their past hirings to predict who the best candidates would be, and all the women, there were no women recommended. But that was so obvious, they just threw it out throughout the system. But there are other companies very much trying to build these systems to have less bias, and there are examples, like I read about child protective services in the US have actually found that their algorithmic risk, they have this risk tool for assessing how high is a child at risk of being harmed if left in the home, and apparently that tool is less biased than the humans who you know, visit homes and consider whether or not someone is biased. So obviously you can do it, but incredibly hard. And I'm not even sure if you can do it with machine learning that's based on big data sets, because what would you do to those data sets? I mean, how can you remove all bias from the history of the world? It's training things on historical data, it's going to be biased.
Yeah, but at least you can find the bias then in this algorithm. You can test them. And I also think this is very interesting, because it's much easier to fix an algorithm than fix the bias within each and every one of us. So as I see it, AI can actually be used in a positive way to fix the kind of bias in the humanity. So I think it's much easier to fix algorithms, at least, than fix our own biases.
Love your optimism. And
I hope so. That's one question more. Trine Rogg Korsvik, how do gender matter in the use of AI in medicine health services? How do gender matter in the use of AI in medicine and health services?
The obvious answer is that so many more studies have been done on men, that there is more data about men still, although that is improving in health. I mean, potentially AI could help if you are, but one of the reasons that medical studies weren't done on women previously was because of the shifting hormones throughout the month. And potentially, I would imagine that using machine learning and actually taking that into account would make it much easier to actually analyze and figure out how medicines, for instance, work at different times of a cycle. I think it's mostly a case of just being aware of it, and it's probably not only gender that's an issue either, but other factors like age or where you live, what you work with, and stuff like that. It's a huge question, though. I'd love to hear back from them how they think it affects it.
Oh, you're just in the beginning of the AI age, and we will have to deal with these questions for the decades to come, I think. Do anyone have more questions? Yeah, one more were popping up. Arnoldo Frigesi, interesting point you made, citing Leonard Davis about statistics focusing on means and thus defining a non-existing norm. I think the most interesting concept in statistics is the variance, not the mean. Variance means recognizing diversity and giving value to it. So that's maybe more of a comment.
Yes, but a really good comment. Okay, so I'd really love to hear from people what they, but it doesn't quite work in the webinar format. Like, what does this, how can you build an AI for variance then that really, that's not overfitted, that actually notices all the differences? Is that possible?
I can open up for Arnoldo to chat, I think. Let's see if I make it, Arnoldo. Let's see. Can I open his microphone? Hello to talk.
Hello, excellent.
Yeah, hi Arnoldo. If you want to talk,
unmute. Maybe I have to click here.
Yeah, now you're online, Arnoldo. If you want to comment.
No, I'm thinking that you mentioned this synthetic data also, Jill, on the fact that it represents, in fact, the extremes of reality better than real data, right? And I think this exploration that you can do of diversity by artificially, in some sense, I think it's a very important point, and maybe it's more important than just the reproduction of the norm.
And there seems to be something about how you generate the synthetic data that
Yeah.
sort of normalizes things, or else it generates these quite alien things that we don't even quite.
Yeah, you showed this beautiful.
Yeah. So there's obviously a lot happening in that process that that can go in wildly different directions. Something to be very aware of. Yeah. Another aspect of synthetic data is like when we train, for instance, I talked to some people developing a system like drones that would recognize faulty power cables in the Norwegian mountains. But they were training their drone or their software on it was American data, but it wasn't even American video of power cables. It was from a video game where there were a lot of power cables. So it was a simulation of American power cables that we were training it on to recognize Norwegian. I mean, there's so many levels of what the data really is, and the synthetic nature of it. That it's
and one key point is that you're making again now is that data must be seen in the context of what is the task, what is the objective, what do people want to do with this data, right? And the aim and objective is in some sense more important than the data to start with, right?
That's right. But then in a lot of projects, if you don't have enormous amount of research, resources, you're probably using a data set that was trained for one purpose, and then you might be, or a data set collected for one purpose, and then you're reusing that data set. And then maybe you're using a model that's trained on a data set. Like, for instance, I talked recently with someone who they were trying to do natural language processing and so forth, and of a set of horror stories, but they were using a neural network that had been trained on Twitter, because Twitter has a huge data set available. And so the valence was very different, right? People talk about different things on Twitter than they do in horror stories. And so the results, like there's so many levels where things can, well, not necessarily go wrong, but go weird.
Transfer learning is a big field, right?
Yeah.
Thank you.
I think we could continue this discussion for the whole evening. But do anyone have more questions now? Yeah. No, just thank you. I think we will just sum up then and say thank you very much to Jill Walker Rettberg. Thank you for a great presentation and these big questions that will, I think, haunt us, and we have to solve them. And all these privacy and bias issues is extremely important in artificial intelligence. So thank you very much, Jill, for a great talk.
Thank you very much for having me. It's been a pleasure.
Thank you.